So let's remember in protein synthesis, we're taking DNA and eventually we're making a protein from that code. But there's two steps. So remember, the first step is making RNA from the DNA, and that's going to be transcription. So it's like jotting down a little note. We're just taking the DNA code and we're jotting it down into RNA. So remember, in our complementary base pairing, in this case, because we're using RNA, A is going to go to U. So if I give you some DNA and then ask to transcribe it, so you're going to give the complementary RNA sequence, which is exactly the same as doing that for DNA, except again, remember, you're going to use the U instead of a T. So here we have the picture of transcription. So I have the double-stranded DNA, and then this enzyme is transcribing the code within the DNA into mRNA. So now that DNA code can be taken by the mRNA to the ribosome where it can be translated into the protein. So, like I said, the next step, once we've got the RNA, we're going to translate it into the protein. So, think of the ribosome kind of like a little factory. This is what actually puts the proteins together. Now, the factory needs instructions about what to put together. So this represents the mRNA. So it's bringing that DNA code, that gene that says what to make in terms of the protein. Once it has the code, then we need materials. So these are our amino acids because they're what gets put together to make a protein. The trucks or the tRNAs are going to bring those amino acids to the ribosome. And then the factory is going to put those materials together. So the ribosome is going to put those amino acids together to make the protein, which is the final product. So again, if we look at it like this, we've got the mRNA, the ribosome, amino acids being brought by the tRNAs, and then the ribosomes putting them together based on the RNA code to make the protein. So again, if you have DNA, you have to transcribe first. You can only translate RNA. But once you have the RNA, then you can translate it into the protein, but you have to have this codon chart. So remember, each RNA codon is going to be translated into an amino acid. So however many codons you have, that's how many amino acids you're going to have. And you use this chart to figure out which one is which. So in this case, I have 4 codons. So I'm going to end up with 4 amino acids in this protein.